Alright, this is a quick video on ratios and proportions. So the first thing we're going to do is get some vocabulary. We're going to start with a ratio. Basic definition for a ratio is a comparison between two values. Now, really we could have a ratio that compares 3 or 4 or even more values, but for what we're going to do here, very basic, we're only going to compare two values. There's several different ways we can express a ratio. First way is with colon. So we would say, for example, 2 colon 3, and then that would be the ratio 2 to 3. And that's one way we would express those values, that 2 is related to 3. Another way we can do it is as a fraction. So we could do 2 with a fraction bar and then 3, or if you like, 2 over 3 like that. Both of them are the same, they mean the same thing, just look differently, and it's still written 2 to 3. The last way to represent it is that we could write it out in words. We could write out 2 to 3. Now all of those are different ways to express a ratio. Now ratio is tied directly into proportions, because a proportion is when we have two equal ratios. And I'm sure most of you have seen this before. It's where we have a fraction, say x over y, and then that is equal to another fraction, a over b. And they're equal to each other. If we reduced them down, they would be the same fraction on both sides. Now typically, one value in the proportion is a variable, or there is a variable somewhere in the proportion, and you're going to be asked to find the variable. So to solve this, to solve a proportion, big idea is that you cross multiply. So if we go back to our example up here, we would multiply the y and the a, and the x and the b. We go diagonally across and multiply those values together. We've got two examples here and then a word problem that we're going to look at. They start easy and then they progressively get harder as we go through. So very easy example first. We have 4/7, or 4 over 7 is equal to x over 84. Now if we want to solve that, we're going to cross multiply. And then, very easy to write this out, 7 times x is 7x. And that's going to equal whatever 4 times 84 is. And we can put that in the calculator and figure out what that is. And 4 times 84 is 336. And then we solve this like we would normally solve an equation. We would divide both sides by 7 to get the x by itself, and x ends up being 48. And then we found the value that would finish out our proportion. Now, the second example here is a little different, because in our second ratio, in our second fraction, we don't just have a variable, we have an expression. We have 2x plus 3. So we solve it a little differently. There's going to be one extra step in the problem, one extra step of work. Not anything that difficult, but just one extra step of work that you're going to need to show. Okay, so we're going to multiply, we're going to cross multiply, and here's the extra step. I actually want you to write this out. We're going to do 3 times 2x plus 3. And the reason we do that is because that 3 has to get distributed to both things in the expression on the other side. So this 3 has to go to both the 2x and the 3. You have to distribute it through. Well, 3 times 2x is 6x, and then 3 times 3 is 9. So this side, when we cross multiply, is really 6x plus 9. Then we multiply the other side, 5 times 27, which ends up being 135. And then we solve this like we normally would for the variable. So we would subtract 9. 6x equals 126 when we subtract 135 minus 9. And then we divide both sides by 6. So x ends up being 21. And then that's our answer to the problem. We found the value, not what the numerator or the denominator of the fraction would be. We found the value that would go into the expression, the 2x plus 3, that would make our proportion, or make our ratios equal to each other to make a proportion. And that value would be 21. Now, last thing we're going to look at here is a word problem. And for our word problem, there's a key step. Obviously, you're going to read it. It's going to have words and numbers. You've got to decide what goes where. But in the key step in the setup, when you're setting up your proportion, because you're going to have to do that on your own, you need to make sure that the parts go in the same place. So, for example, we have, say we're talking about miles here, okay, on the top. And then on the bottom, we're going to put time. Okay, when we set that equal to our other one, we need to make sure that the top continues to be miles and the bottom continues to be time. Now, this is very basic. They're not all going to be miles in time or distance in time. But what you need to do is make sure that they match up across, okay? Or they match up on top of each other. So miles over miles equals time over time. Now, that can get a little trickier because it's easier to get your time and your miles confused and get one of your fractions, one of your ratios mixed up. So I would like you to try to set it up like this, where you have one piece of the problem and then a second piece, the second piece. One of those will be a variable that you're trying to find, but you set up one ratio with two different measurements, and in the second ratio, those measurements match up in the same place, either in the numerator or the denominator. Okay, so let's look at our example here. It says a piece of cable 8.5 centimeters long weighs 52 grams. What will a 10 centimeter piece of the same cable weigh? So we're going to start by putting the 8.5 over the 52. Now this is important because this is what I was talking about earlier. We've put the centimeters over the weight, over the grams in this case. Okay? Now when we set up our other proportion, we need to make sure that the centimeters stay on top and then the grams would go on the bottom. And they give us one other piece of information. They only give us that we're looking for a 10 centimeter piece. So that goes on top, and we're looking for the weight. So our weight would be what we're trying to find, the x here. And then there's our proportion. Okay, so the centimeters are on top, and the weight, the grams, are on the bottom. Now you could have that flipped. You could put the grams on top and the centimeters on the bottom. As long as you're consistent and have them lined up across, you're perfectly fine. You're going to get the same answer either way. So we would solve this by cross-multiplying. 8.5 times x is 8.5x, and that's going to equal 52 times 10, which is 520. And then we solve this like we normally would. We would divide both sides by 8.5, and we get x being about 61.2. Now you do get a decimal, and they rounded to the 10th place in the problem. Normally it would tell you if you needed to round to something, but they have it to the 10th place in the problem, so we're just going to go to one decimal here. Okay, and 61.2 would be our answer. Now, key for a word problem. I will take points off because this needs to have a label, since it has a label in the problem. We're talking about grams here, so we need 61.2 grams. Okay, ratios and proportions aren't really that difficult, but the key, especially for those word problems, is that you're setting them up in the right spots, that things are consistent, either both in the top or both in the bottom. And then when you're cross-multiplying, especially when you have an expression on one of those ratios and one of those fractions, is that you distribute through. Those are both common mistakes. So if you have any questions, make sure you bring them to class next time.